Now let's look at the relationship between present value and time and rate of return. And everything that we said about the future value and time and rate of return can be turned in reverse. The greater the interest rate or the discount rate, the smaller the present value. That means the smaller amount you need in the form of today's dollars in order to grow to the same amount sometime in the future. And this is how this graph is represented. This is how much you need to collect $1 at some point in the future in today's dollars. So at 20% interest here for 10 years, I would only need 20 cents to get $1 in 10 years. At a lower interest rate, you can see at zero, if I wanted $1, I would have to have $1. And then as the interest rate increases, the amount I need goes down. The longer the investment is held, also the smaller the present value. So the relationship between the present value and time and the relationship between the present value and rate of return are inversely related. Time, once again, has the greatest influence on present value. So let's take a step here to talk about what we've learned up to this point. An important financial principle from this book says that the present value of any financial asset depends on the usable after-tax cash flow it is expected to produce in the future. This is because of time value of money. Due to time value of money, we have to discount those expected future cash flows to determine the present value of the asset. Thus, the overriding, all-important, never-to-be-forgotten financial process is this valuation process that says the theoretical or fair market value of any financial asset is determined by discounting all future expected cash flows to the present. Not all will agree on what those future expected cash flows are, but we all can agree on how they should be discounted. Now let's move on to other points where we'll be talking about ways that we can solve for other than just present and future value. Your broker proposes an investment scheme that will pay $1,000 2 years from now for an initial cost of $900 today. You want to compare it to other investment opportunities, so you need to calculate an annual rate of return. Now, this may sound a little complicated, but with the financial calculator, it is the same process. It's just now we're going to ask the calculator to compute the rate or the interest rate per period. In the method one, we can solve this directly or numerically by plugging in the values into our financial time value money function. So we will receive $1,000 for a $900 investment. The interest rate is unknown, and we will invest for 2 years. Let's solve this using our calculator. So once again, I will clear time value of money. I will clear my payments per year, make sure my payments per year function is set at 1. And then I will put in my input. So I'm going to invest for 2 years. I don't know what the interest rate will be. I do know that I will invest $900. I'm going to make that a negative representing an outflow. And I'm going to receive $1,000. That will be positive, representing an inflow. I could get the same interest rate if I reversed the signs, but if I had both positive signs or both of them negative signs, I would get an error, actually an error 5 on this calculator. Now I hit compute interest rate. I see that I can make 5.409% per year. Now, this interest rate takes into account compounding. Why can't we just use the new minus old function that we learned in the first segment, the first chapter of this book? Because if we calculate the new minus old, we're going to invest $900, receive $1,000, so that's a $900 profit or $100 profit on a $900 investment. That would be an 11.1111% return. Dividing that by 2, we would get something more than 5.049%. The 5.409% takes into account the effects of compounding. I would be getting 5.409 the first period, but then also the same interest rate on the interest collected the second period. Let's also look at a problem where we can solve for the number of periods. So, how long will it take to double an investment of $1,000 at 6% annual interest? Solving this numerically, I could once again use my time value of money, present value functions. I would start with $1,000. I would receive $2,000. I have a 6% rate of interest, but now n is an exponent. In order to solve for a variable that is an exponent, I would need to take the natural log of both sides and then divide to solve for n. So we can see numerically that we would take 11.895 years. Let's solve this using our calculator. So I'll clear my work, clear time value of money. Make sure that my payments per year function is still set at 1. Now we are going to solve for the number of periods. We know that we have a 6% interest. We have a $1,000 investment, and it could be any investment, just as long as you double it. We're going to receive $2,000 and compute the number of time periods. Now, in this case, this number of time periods are going to be in the same number as we've reported as an interest rate. So if we receive an interest rate annually, this tells us that n is 11.89 years.